Hi guys, welcome to the notes for quadratic applications in regression. It's the last section of notes for about quadratics in Unit 7. Our essential question is, how can quadratics be used to model and solve world problems? Okay, so we're going to begin with number 1. Number 1 has, I think, 5 parts, so it is kind of long, but it's all based on the same equation here. Okay, so Timmy has a t-shirt cannon that models the path h of t equals negative 16t squared plus 72t. where t is the time in seconds and h is the height in meters. So t is the time in seconds, so that's kind of important because we do need to know what t represents, and so sometimes it's like, well, what are we looking for, and we have no idea. So I'm going to highlight t for the time and h for the height in meters, because that is important. All right, so we have 2 variables here, and so h of t is basically as a function, but they could have just put h if they really wanted to. So here we're talking about how high is a t-shirt at 2 seconds. So we're given the function h of t equals negative 16t squared plus 72t, and we're asked to find how high. So are we asked to find the height or the time here? We're asked to find the height, and we're given 2 seconds. So we want to know at 2 seconds, how high is this t-shirt that has been shot out of the cannon? So I'm going to plug in 2 seconds for my time. So I'm going to take h of 2 and then plug in a 2 anywhere I see a t to solve this. Okay. Let me go ahead and plug that in. Now this h of 2 over here on the side doesn't really do anything. It doesn't change or affect our answer in any way. It's just stating that, hey, I'm plugging in a 2 into this function. That's really all it's doing. All right, and so once you plug that into your calculator, you should get h of 2 equaling 80. So what does that mean for our answer? That means that at 2 seconds, the height of the t-shirt is 80 meters. So that's how high it is after 2 seconds. Okay? Part B is talking about what is the maximum height. So we're going to go ahead and graph this. So I'm going to go ahead and switch to my camera so that you guys can see that. Okay, so here's just my work for solving that last problem. So I'm going to, sorry, my nails say beautiful on them because we have stickers made and there's a little bean on them, beautiful beans. All right, so you're going to hit y equals and then you're going to graph. So, oh, I need to write down the equation somewhere. What was it? It was, let me go ahead and write that on a piece of paper so I don't forget. Wow, this seems like a really botched job, honestly. Okay, so we have negative 16t squared plus 72t. Is that right? All right, so this is the, well, where is it? This is the equation that we were given. I know that's really bad handwriting, but anyways. Now we can't insert a t into the calculator, but we can insert an x. So I'm going to type in, I hope this glare is not going to be a huge issue. So I have negative 16x squared plus 72x. So I'm going to go ahead and do I'm going to do graph, actually. I'm not going to do second graph. So I'm just going to hit graph, and I'm going to look at the graph that I'm given. Okay, so here is my graph. And let's go back to this problem. So now my question to you is, do you think that this parabola opens up or will it open down? So is it going to look like this or is it going to look like that? Okay, the graph for this does open down, and actually we knew that before we could have even began because our a is negative here. So that tells us if it's going to open down or not. Oh, whoops. So I'm going to go ahead and sketch it really quick. Now I know that we can't really see the maximum point or the vertex on here, but it looks something like this. 1, 2, 3, 4, 5. Okay. Oops. So we have our graph, and it looks something like this. So I know that it's going to go up, and then it's going to curve up at the top. I just can't see it because it's kind of too far zoomed in. But I'm asked to find the maximum height here. So I'm asked to find maximum height, which means I need to use my calculator to help me do that. So the first step we're going to do is we're going to graph, and we already did that. The second step is to hit second trace, okay? And then we have left bound, right bound, and guess. And then we're missing this step here. So we're going to fill in this step really quick. So let me go over here and show you, okay? So we're going to hit, we already graphed, so we're going to do second trace. Now we're asked to find the maximum height. So the most the most reasonable thing to click on would be maximum. So I'm going to type in number 4, and then ask me for the left bound. Now, what does left bound and right bound mean? So let me go ahead and fill in this part where it says maximum, which is number 4. And also, if your parabola opened up, you would have to find the minimum. So it just depends on the problem that you have. Okay, so left bound and right bound basically is telling my calculator, where should I look for this vertex? In what area? So for example, if you ask the calculator to do the left bound of like, let's say, -4 to -1, okay, it's going to look in this area only. And it's like, well, I'm confused. There's no vertex over here. There's no maximum here. So it doesn't know where to look. Let me erase all this really quick. Okay, so you want to put your dotted lines or your bounds in a reasonable area. So I think I'm going to do my left bound at -1. So I'm going to do a left bound at -1, and I'll show you that in a second. And then my right bound is going to be, let's do 5. Now, again, left bound and right bound are just telling your calculator where to look. Okay, there we go. All right, so for my left bound, I'm going to type in a -1. Now, when I type in a -1, do you see how there's a dotted line at -1? It's trying to bound it and be like, okay, where am I supposed to look? And then my right bound, which it's asking for, I'm going to type in a 5, because that's what I said I was going to do. So we're going to do 5. And so now it's trapped in between -1 and 5. And it's like, okay, look in this area, calculator. Look for the vertex in this area. Because if my dotted lines were over here, then it'd be like, well, I don't know where I'm looking. And then for guess, you just hit enter. So all you have to do is just hit enter. Okay, so you're given x equals 2.24999, and then y equals 81. So let's go back here. So that means that we got the point. We got the point 2.25 about, I'm going to round that, and then 81. Now the question was, what is the maximum height? So do you think that the maximum height would have been the x value or the y value? Do you think it's 2.25 or 81? And the answer to this one is it's going to be 81. Remember, x is our time, which is our seconds. So our y value is going to give us the height. Okay, so at the maximum height, it is 81 meters. That's the max that my t-shirt can go up to. The second part is asking, when will the t-shirt reach its maximum height? So it's asking when. So we know what the maximum height is, but when is it going to reach that? It's going to reach that at 2.25 seconds. About, obviously, because we rounded. Okay. All right, now D is when will the t-shirt hit the ground? So I'm going to go ahead and draw that graph again really quick on here. Whoops. Okay, so I'm just going to draw that graph again on my little area over here just to sketch it. Now, here, let's ask. Or let me ask you this question. What does this point represent? What is that point? We're 0 seconds and 0 meters. That means that is where your t-shirt has started. It hasn't shot off out of the cannon yet. It's still there on the ground pretty much, or inside the cannon. And then your t-shirt is shot up. So it's talking about the distance, how high it's going up. It's not talking about where, like how away from you, but it's just talking about how high up it is. And then it hits its maximum height of 81, and then it goes back down. Now let me ask you this. What does this point represent? That point represents when the t-shirt lands on the ground. So we're technically looking for an x-intercept here. We're looking for this guy. So I'm going to look for an x-intercept. And when I look for an x-intercept using my second trace, I'm always going to select the 0 option. And then I do my left bound, my right bound, and my guess. Okay. Now, let's talk about left bound and right bound for this x-intercept here. I want to look for this x-intercept, okay? I don't want to be looking for this x-intercept. So I do want to tell my calculator just to look in this area, because if I make the area too wide, it doesn't know where to look. So your left bound can be any number to the left of this point, but it can't go past this one because it can only contain one x-intercept. So I think I want to make my x-intercept +3, and then maybe my right bound to be 6. So my left bound is 3, my right bound is going to be 6. So let's go ahead and go do that in our calculator. All right, so I'm going to do second trace, okay? And then I'm going to do 0, and it's asking for the left bound. So I'm just going to type in +3, because I know that 3 is kind of like in the middle here, and it's not too far that way. Okay, you see how there's a dotted line here? It's saying, okay, I'm going to look anywhere to this part, anywhere to the right of this, and then I need a right bound. So my right bound I'm going to select is going to be 6. Whoops, I mute my phone. Okay, type in 6. And then you see how it's contained in these two things. These dotted lines are squishing this x-intercept in the middle. And for guess, I hit enter, and I get 4.5, 0. So I'm going to go ahead and go back to the notes. So I have 4.5, 0. So what does the x value stand for? It represents our time. So at 4.5 seconds is at 0. The height is 0 meters, which means it's on the ground, okay? So that means it's going to be 4.5 seconds. Now I actually didn't have to do any work for this one. If you look back at part B. Part B, I know that my maximum height was at 81 meters. It took 2.25 seconds to get up there. It's also going to take the same amount of time for it to fall down. Now, obviously, that's not very realistic because we're not considering gravity, we're not considering wind force, we're not considering any of that stuff. So in a perfect world where there's no gravity or anything like that, not no gravity, but like no wind resistance is what I mean. If there's no wind resistance, then it's going to take the same amount of time it takes to go up as it is to go down. So if it takes 2.25 seconds to get up, it's also going to take 2.25 seconds to get down. Well, 2.25 plus 2.25 gives me a 4.5 seconds for it to land on the ground again. So that one's one of those, like, if you can, like, use your common sense, perfect. All right, now we're going to talk about domain and range here. So we have domain and we have range. Now our domain has to do with our x values, but we haven't been using x, so our x-axis has represented what? It's represented time, okay? Time in seconds. So I know that my domain's going to have something to do with a t, and I know it's going to be bounded because there can be a maximum and a minimum amount of time. Now, what is the minimum amount of time that I could ever even start at? Well, the minimum amount of time I could start at is 0 seconds. I don't have to, at the very beginning, you're at 0 seconds. But my time can equal 0 seconds, so I will have an equal to there. Now, what's the most amount of time it's going to take for my t-shirt to land? 4.5 seconds, and it can also equal to that. Now my range is my y values. It's talking about how high the t-shirt is going. So that's our height, okay? And the minimum height of my t-shirt is 0 because it starts off at the ground, and it can equal 0. And my maximum height is 81. Remember, because we solved for the maximum height earlier for 81. And it can also equal 81. So our reasonable domain and range would be those two sets of, or those two ends would be 0 to 4.5 seconds and 0 to 81 meters. All right, number 2 is all in the calculator. So if you don't have a calculator at home, you're going to have to come up to school and probably borrow one to do this part of the homework. All right, so we're going to use quadratic regression to find a model for the data in the table. Now, I don't know if you remember, this might have been, I think, either Unit 3 or Unit 4, but you were given like a graph like this, and you had to plot some points on it. And then it asked you to use linear regression, so your calculator did its best job to create a line that kind of went through those points. Okay, do you kind of remember this? With quadratic regression, you have the same kind of concept. You're given points, but it's more of like in a U shape. So your calculator is trying to do its best job to find a graph that will fit all those points. Okay, so we're going to use quadratic regression here. So the first thing we're going to do is talk about our steps. So before you even touch a calculator, if you have one, I'm going to talk about the steps. The first step you're going to do is you're going to hit stat, and then you're going to go to edit and hit enter. And then the next thing you're going to do is you're going to type in your L1 and L2. So these are your lists of numbers. Then you'll do stat again, move over to calc, and then you're going to do something here, which is very important, and then you're going to hit calculate. Now we'll talk about this step in a second. Okay, so let's go ahead and try this. Okay, so I'm going to hit stat on my calculator. Okay, and then you see how it is already hovering over edit. I just need to hit enter. Okay, and I'm given all of these lists. So you're like, well, what do I put in those lists? I don't know. All right, so L1 is always going to be your independent. It's going to be your like X values, basically. So in this case, that's going to be my time, and my height's going to be my L2. Okay, so I want to make sure that I type this in correctly. So I have 0, enter 1, enter 2, 3, 4, 5, 6. Okay, and then I have 9734. So I'm going to move over to L2, and I have 9734, and I have 8, 10, 19. All right, now there's two things you should always check for when you're entering in these lists. The first thing you should check for, make sure the amount of things in each column matches up. So if there's 7 things over here, then there should be 7 things in the second column. The next thing you should always check for is that you make sure that you enter these in exactly the way it was on the table. If you type in just one number wrong, your calculator is going to give you a different equation. Okay, so after I do my L1 and L2, I'm going to hit Stat and do Calc. So I'm going to hit Stat here, and then I'm going to move over to the right, and you see how it says Calc? And then I have all of these options here. Now this unit is about quadratic, so we need to do quadratic regression. So you need to look through these choices and think about which one of these would be quadratic regression. Well, you see number 5 how it says quad reg, that's the one we're going to select. So in here, I'm going to type in number 5 for quadratic regression. Okay, and once I select number 5, once I select quadratic regression, 5, it's going to give me this whole list, and all I need to do is just go down and hit calculate. All right, so it's giving me all of this. So I'm going to go ahead and go to my notes and copy this stuff down. So my calculator gave me the standard form of a quadratic. And it also gave me values for A, B, and C. So it's saying that A, whoops, I meant to put red. It's saying that A is 1.0833, B is negative 5.0357, and C is 9.5952. Okay, so it's giving me A, B, and C. Well, I'm asked to find a model for this data, which means I need to find an equation. Well, I'm given standard form, and they gave me A, B, and C, so the thing that makes the most sense is to take A, B, and C and plug that back in. So I'm going to plug in the A value, so I have 1.08, and I'm going to go ahead and keep the 2 decimal places. Okay. My B value would be negative 5.04x, okay, or my B value is negative 5.04. I'm going to round again to 2 decimal places. And then my C value would be 9.60. So that is my model for this data. So I'm saying that that's my best representation for this table, which is what my calculator came up with. Now again, you type in one of these numbers wrong, you type in an 8 there on accident, bad news bears, okay? Because you're going to get a different equation. So automatically, this part would be wrong because your equation wouldn't have been right to begin with. All right, so let's talk about the next part. It's asking, what is the height at 10 seconds? So I'm given an equation. I'm given this right here, or I've created an equation thanks to my calculator. All right. Now it's asking for the height at 10 seconds. So I'm looking for the height. And the height would be my y values because seconds would be my x values because it's time, and time is always independent. So I'm going to input a 10 anywhere I see an x. So I'm obviously solving for y here because I no longer have x's because I'm plugging a 10 anywhere I see a x or see an x. So I'll go ahead and highlight that so it's a little easier to see. So I have x, 10, 10, and I know that's going to be 10 seconds. Okay. Once I plug all of that in, you can literally straight up plug all of this stuff into your calculator. So let's see. All right, I got y equals 67.2. Okay, now what does that mean? It means at 10 seconds, the height of whatever we're talking about is at 67.2 feet. Okay, so that's the height at 10 seconds. All right, moving on to number 3. Now number 3 is something that we saw in Unit 5 when we were doing systems of equations, but you can use your calculator to help you solve this as well. So the width of a rectangle is 5 less than, now I meant to put twice here, so I forgot, it's kind of late when I was making these notes, so it should be 5 less than twice the length. And the area is 322 square feet, so we need to find the dimensions. Now when it's asking to find the dimensions, it's asking us to find the length and the width. Well, I know I'm given area here, and I know area is, wow, that was weird, is length times width. And I know area, it gives me area, which is 322. Okay, I'm gonna go ahead and underline that, I guess. And I kind of underlined it. Okay. Now, let's talk about the equation that it gave us. It's telling me that the width of the rectangle is 5 less than twice the length. Okay. Now, what does is mean in math? In math, is means equals, okay? It's saying the width of a rectangle is. So we have W equals width is, okay. 5 less than twice the length. So I have twice the length, and I have 5 less than that. So I'm going to take away 5, okay? Now, Unit 1, we said less than and more than were turnaround words. So instead of a minus 5 in the front, you have a minus 5 in the back, even though minus 5 comes first in the sentence. So next part, you know that the width equals 2L minus 5. So you're going to input that in here. You're going to use substitution. So you have 322 equals length times 2L minus 5. Okay? Now, here you'd be like, well, Miss, like, let's just distribute. Like, let's just do that. And like, you can. It's not a big deal. You can, but you don't have to is what I meant to say. You can distribute the L, but you do not have to. And I'm not going to because, you know, I'm lazy. And math people are lazy and we don't always have to do everything. So you can either use that or you can use this, which is when it's distributed in. So either way works. They're equivalent. Now, we don't need to distribute, and the reason why we don't need to is because we're not solving ourselves. We're using our calculator. So our calculator can handle that. But in order to graph this, I need my equation equal to 0. So I'm going to go ahead and subtract 322 on both sides. And these are L's, by the way. These are L's. They're not parentheses. Okay. The next thing we're going to do here is we're going to graph this. So I'm going to go to my calculator over here. Now, obviously, I can't put an L in a calculator, but let me write this. So I have L. Let me put these down really quick so I can write kind of nice. Okay. So I have this, and I need to insert this into my calculator. Now, this is the equation from earlier, so I'm going to clear that. And we can't put L's in the calculator, so we're going to have to use X's. So we have X, and then we have parentheses, 2X minus 5 minus 322. So that's what I have. And then I'm going to hit second graph because I want to look at this table really quick. Now, yes, there should be very large numbers. And the reason why is because we have minus 322 on there. So that's going to affect a lot of things. Now, let me ask you. There's a 0 in for technically your y value, right? Like usually you have y equals something. So this is technically in for your y value. And when this is set for your y value, you're always looking for the x-intercept, or in this case, the L-intercept. Now, x-intercepts have the form, can't find my paper, number, comma, 0, okay? So I'm going to scroll down and look for number, comma, 0 somewhere. Aha, I see it, 14, 0. So let me go back to my math here. So I have a x and y table, and I'm looking for the y-intercept. So I have 14, comma, 0. Not y-intercept, x-intercept. Look for x-intercept, okay? Because we're solving for that value. Now, obviously, we didn't use x and y in our problem, but our x-intercept here represents our length because that's what it is here. Instead of an x, we have L's. So that means that the length is 14. Whoops. 14 feet. Okay. What does that mean? Well, we still need to find the width, but I know that the width equals, from earlier, 2 times the length minus 5 from here. So I'm going to take the length, which is 14, and substitute it in. And I get that the width is 23 feet. So my dimensions are 14 by 23 feet, okay? So yeah, Again, probably not the easiest way. Substitution or elimination probably would have worked fine. The issue is that we're talking about quadratics here, and we want to know how to solve them in a calculator. So that's what it is. All right, this is the last problem in the notes, which is our intercept factored form, kind of quotation marks there. So the intercept form is just a different way to write quadratics. So notice how we have two sets of factors there. We have x minus something and x minus something. Now the p and q, which are in that form, represent x-intercepts. So let me go review something really quick. So if I have 0 equals x minus 2 and x plus 7, let's say I had that. So let's say we solved by factoring, and then I end up factoring and I get this. Well, if we remember by solving by factoring, I know that this times this equals 0. If that's the case, then either x minus 2 is 0 or x plus 7 is 0. But since I don't know, I set them both equal to 0. When we're solved by factoring. Okay, that means x here would equal 2, and x over here would equal negative 7, because you're solving for x. Now, what do you notice about the signs? You have negative 2 here and positive 2. You have positive 7 here and negative 7. Your signs are opposite, okay? So when we're talking about p and q, we have opposite signs. Now, I know that I'm supposed to write it in this form, the factored form, okay? So let's go ahead and identify our x-intercepts. So our first x-intercept over here is at negative 3, 0, and our other one is at 5, 0. So I have two x-intercepts. So go ahead and rewrite this. I know that my first one, is going to be x, and then if my first intercept is negative 3, I'm going to use a plus 3 in the parentheses in my factored form. Remember, because your factors and your intercepts have different signs, just like up here. Different signs. We had negative 2, and then our x-intercept was 2. Over here, we have x minus 5, okay? Because we have a positive 5 for x-intercept, and now it's negative. The problem is, we don't know what our a value is. So we need to solve for it. Well, in order to solve for a value, the a must be the only thing left in the equation, which means I need to plug in something for an x and my y's. So, do I have a point on this graph somewhere that I could plug in for x and y? Yeah, whoa. Yeah, I do. This point right here, our point negative 1, 6, so x comma y, okay? So anywhere I see an x or y, I'm going to plug in that point. So for y, I have a 6, and then I'm going to go ahead and leave everything in blue that was originally there already, okay? And then the x value is going to be negative 1 here, and then negative 1 here. So all of the greens is where I plugged in that point that I had on my parabola. And now I'm going to simplify. So I have negative 1 plus 3, which is positive 2. And I have negative 1 minus 5, which is negative 6. And then I have 2 times negative 6, which is negative 2. Okay, and I want a by itself, so I'm going to divide both sides by negative 12. And simplified, that gives me a equals negative 1/2. Okay, now that's not my answer, that's my a value. So I want to go ahead and plug in my a value back into the equation that I had up here. So I have y equals negative 1/2 x plus 3 x minus 5. So this is my factored form or my intercept form. You're giving your a value, and I don't know if you've noticed, but you have a value in all forms. You have it in standard, you have it in vertex, and you also have it in factored form. But that is it for these notes. If you